Hello everybody, welcome to my YouTube channel. Today we're gonna be talking about basic calculus, finding the area under the curve using integration. Let's get right into it. So, you might be asking, what exactly do you mean by that? Well, finding the area under a curve using integration involves using a definite integral to calculate the area between the curve and the x-axis within specified limits. So here are the parts of finding the area using integration. The function is y is equals to f of x. This represents the curve whose area you want to calculate. Then over here, limits of integration a and b. These are the values that define the boundaries of the area you're interested in on the x-axis. Here is the formula for finding the area under the curve. As you can see, I'm showing the integral symbol, which indicates the integration process, then the a and b, which are the limits of integration, which specify the lower and upper bounds of the area, then the f of x, which is the function which represents the curve's equation, then dx, which means differential. This indicates that the integration is performed with respect to x. Here we have the steps to calculate the area. First, you determine the function and the limits of a and b. You'll need the equation of the curve and the x values where the area begins and ends. Then next, number 2, we have to calculate the indefinite integral of f of x by finding the antiderivative of f of x. Then third, we evaluate the indefinite integral at the limits a and b by substituting the values of b and a into the antiderivative. Then 4, we have to subtract the result from b to a, and the difference gives you the area under the curve between x is equals to a and x is equals to b. Here are real-life examples of where finding the area can be applied: engineering, agriculture, and transportation. So now, we have our first example. Find the area underneath the curve y is equals to negative sign, open parenthesis, x minus 4, close parenthesis, raised to 2 plus 6, and above the axis from x equals 2 to x is equals 5. So first we sketch the graph. X is equals to 2, 3, 4, and 5. So we have to find the y values. To find the y values, we substitute 2, 3, 4, and 5 into the equation. And by getting the equation, we get 2, 5, 6, and 5. Those are gonna be the values for the y-axis. And now, next, we plot the points, as you can see in the second page. So now, we have to find the area. We show the upper and lower limits, which are 5 and 2, then the function. First, we simplified the function inside. So we go to the fourth step. Negative, open parenthesis, x minus 4, close parenthesis, raised to 2 plus 6 dx turns into negative, open parenthesis, x squared minus 8x plus 16, close parenthesis, plus 6 dx. Then as we further simplify, we're going to place the negative sign outside into the equation. So it will become negative x squared plus 8x minus 16 plus 6. Negative 16 plus 6 turns into negative 10. So now we go into the fifth step. We find the antiderivative. So it becomes negative x raised to 3 over 3 plus 8x squared over 2 minus 10x. And which we simplify 8x squared over 2 into 4x squared. Then next, after that, we substitute the upper and lower limits. So we substitute 5. So it will become negative 5 raised to 3 over 3 plus 4 times 5 raised to 2 minus 10 times 5 minus negative 2 raised to 3 over 3 plus 4 times 2 raised to 2 minus 10 raised to 2. In this slide, we have the fifth step from the previous slide to show where we stopped. So now in the sixth step, we simplify both of those equations. So it will become negative 125 over 3 plus 100 minus 50 minus negative 8 over 3 plus 16 minus 20. If you simplify those two, it will become 25 over 3 minus negative 20 over 3, which can also be written as 25 over 3 plus 20 over 3. If you add those two, it will become 45 over 3. Simplify, and the final answer is going to be 15 square units. That is the area for the first example. And now for our second example, we have to find the area underneath the curve y is equals to 1 plus open parenthesis x squared plus 2x minus 3 close parenthesis, and above the axis from x is equals to 1 to x is equals to 4. So for our first step, we have to sketch the graph. Our x values are 1, 2, 3, and 4. We have to find the y values. As we did earlier, we are going to substitute the x values into the equation to find the y values. And if we do that, we're going to find 1, 6, 13, and 22. Then, as you can see, for the second step, we plot the values on the graph. And now, in this slide, we are going to be finding the area. Our upper and lower limits are 1 and 4. So the area is equals to 4 and 1, then 1 plus x squared plus 2x minus 3 dx. First, we simplify. We add the 1 to the negative 3, so it will become negative 2. Then now we move on to the fifth step. As we can see, we find the antiderivative of the equation. It will become x raised to 3 over 3 plus 2x raised to 2 over 2 minus 2x. Moving on to the sixth step, we substitute the values of 4 and 1 into the equation. So it will become 4 raised to 3 over 3 plus 2 times 4 raised to 2 over 2 minus 2 times 4. Then for the next value, minus 1 raised to 3 over 3 plus 2 times 1 raised to 2 over 2 minus 2 times 1. And now on this slide, we have the sixth step from the previous slide. Now moving on to the seventh step. We simplify both of the equations into 64 over 3 plus 16 minus 8, then minus 1 over 3 plus 1 minus 2. Then moving on to number 8, we simplify again. The first equation will become 88 over 3, then minus 2 the second equation, which is negative 2 over 3. Now this can be written as 88 over 3 plus 2 over 3, which becomes 90 over 3. Now we divide that in the ninth step, and the final answer will become 30 square units. And that is the end of this video. I hope you found this video helpful. Thank you for watching!